The bag of words model is a simplifying representation used in natural language processing and information retrieval. In this model, a text is represented as the bag of its words, disregarding grammar and even word order but keeping multiplicity. Recently, the bag of words model has also been used for computer vision. The bag of words model is commonly used in methods of document classification, where the occurrence of each word is used as a feature for training a classifier. An early reference to bag of words in a linguistic context can be found in Zelig-Harris's 1954 article on distributional structure. Example implementation: the following models a text document using bag of words. Here are two simple text documents. Based on these two text documents, a dictionary is constructed as which has 10 distinct words. And using the indexes of the dictionary, each document is represented by a 10-entry vector, where each entry of the vectors refers to count of the corresponding entry in the dictionary. For example, in the first vector, the first two entries are 1, 2. The first entry corresponds to the word John, which is the first word in the dictionary, and its value is 1, because John appears in the first document one time. Similarly, the second entry corresponds to the word likes, which is the second word in the dictionary, and its value is 2, because likes appears in the first document 2 times. This vector representation does not preserve the order of the words in the original sentences. This kind of representation has several successful applications, for example email filtering. Term weighting: in the example above, the document vectors contain term frequencies. In both IR and text classification, it is common to weigh terms by various schemes, the most popular of which is TF-A-IDF. For the specific purpose of classification, supervised alternatives have been developed that take into account the class label of a document. Additionally, binary weighting is used in place of frequencies for some problems. Hashing trick: a common alternative to the use of dictionaries is the hashing trick, where words are directly mapped to indices with a hashing function. By mapping words to indices directly with a hash function, no memory is required to store a dictionary. Hash collisions are typically dealt with by using freed-up memory to increase the number of hash buckets. In practice, hashing greatly simplifies the implementation of bag of words models and improves their scalability. Example usage: spam filtering. In Bayesian spam filtering, an email message is modeled as an unordered collection of words selected from one of two probability distributions, one representing spam and one representing legitimate email. Imagine that there are two literal bags full of words. One bag is filled with words found in spam messages, and the other bag is filled with words found in legitimate email. While any given word is likely to be found somewhere in both bags, the spam bag will contain spam-related words such as stock, Viagra, and buy much more frequently, while the ham bag will contain more words related to the user's friends or workplace. To classify an email message, the Bayesian spam filter assumes that the message is a pile of words that has been pulled out randomly from one of the two bags, and uses Bayesian probability to determine which bag it is more likely to be. See also, W shingling, N-gram, vector space model, natural language processing, additive smoothing, document classification, machine learning, document term matrix, bag of words model in computer vision, hashing trick, min-hash, feature extraction, references, A.B. Civic, Joseph. Efficient visual search of videos cast as text retrieval. EE Transactions on Pattern Analysis and Machine Intelligence, Volume 31, Number 4. IEEE. PPA 591 Euro 605 Harris, Zelig. Distributional structure. Word 10, 146 Euro 62. And this stock of combinations of elements becomes a factor in the way later choices are made. For language is not merely a bag of words but a tool with particular properties which have been fashioned in the course of its use. Young Co. A study of term weighting schemes using class information for text classification. SIGIR 12. ACM, Weinberger, KQ. Dasgupta A., Langford J., Smoller A., Attenberg, J. Feature hashing for large-scale multitask learning. Proceedings of the 26th Annual International Conference on Machine Learning, 1113 A Euro 1120 A.